Condensation on windows is a common issue in modern buildings, but why does it seem more prevalent today than in older structures? The answer lies in the evolving design of buildings, advancements in insulation, and the interplay between temperature, humidity, and air circulation. In this video, we'll explore the reasons behind increased window condensation in modern buildings and offer insights into managing it effectively. One of the primary reasons modern buildings experience more window condensation is their enhanced insulation and airtight construction. Older buildings often had natural air leaks through cracks, gaps, and less efficient materials, allowing moisture to escape more freely. In contrast, modern energy-efficient buildings are designed to retain heat, which also traps moisture indoors. The higher indoor humidity increases the likelihood of condensation forming on cold surfaces, such as windows. Modern buildings typically feature double or triple glazed windows to improve thermal performance. These multi-pane units significantly reduce heat loss compared to single-pane glass and keep the inner glass surface warmer. As a result, condensation is generally less likely to form on the interior surface. However, if indoor humidity levels are high and ventilation is poor, condensation can still develop, most often around the edges of the glass or on colder window frames where the temperatures remain lower. Modern lifestyles contribute to higher humidity levels. Everyday activities such as cooking, showering, laundry, and even breathing release moisture into the air. Since modern buildings are better sealed, this moisture remains trapped inside, increasing the relative humidity and the potential for condensation on cooler surfaces. Relative humidity, or RH, is the percentage of moisture in the air relative to the maximum amount it can hold at a given temperature. When the relative humidity reaches 100%, excess moisture condenses onto surfaces. In modern, well-sealed buildings, RH tends to be higher, increasing the chances of condensation. The dew point is the temperature at which air becomes saturated with moisture and condensation begins. In a well-insulated building, the indoor temperature remains relatively stable, but if windows are colder than the dew point temperature, condensation will form. The greater the humidity inside, the higher the dew point, meaning condensation can occur at relatively moderate temperatures. Ventilation plays a crucial role in controlling humidity levels in modern buildings. To enhance airflow and reduce condensation, several strategies can be implemented. One effective method is using exhaust fans, particularly in kitchens and bathrooms, to expel excess moisture directly outside. Another approach is opening windows periodically, which allows fresh air to enter and helps balance indoor and outdoor humidity levels. Additionally, installing mechanical ventilation systems such as energy recovery ventilators or ERVs or heat recovery ventilators or HRVs can improve air exchange while maintaining energy efficiency. Reducing indoor humidity levels is essential for minimizing condensation risks. One effective method is using dehumidifiers, which extract excess moisture from the air, especially in high humidity areas. Another approach is adjusting HVAC settings by running air conditioning or using a humidistat to help regulate indoor moisture levels. Additionally, Limiting moisture-generating activities can make a significant difference. Simple actions such as covering pots while cooking and running exhaust fans during showers can effectively reduce indoor humidity. Proper window design can help mitigate condensation issues. Using insulated window frames made of materials like vinyl and fiberglass provide better thermal insulation, reducing temperature differences that contribute to condensation. Installing window films adds an extra layer of insulation, helping to maintain a more consistent glass temperature. Additionally, maintaining airflow near windows by keeping curtains open and ensuring warm air circulates around them can prevent condensation buildup. Modern buildings are designed for energy efficiency, but their airtight nature can lead to increased humidity and, consequently, more window condensation. Understanding the relationship between insulation, indoor humidity, and temperature differences is key to managing condensation effectively. By implementing proper ventilation, humidity control measures, and window insulation techniques, building occupants can enjoy the benefits of energy-efficient homes without the drawbacks of excessive condensation. Learn more about moisture and how the moisture capacity of air is influenced by its temperature by taking a look at last week's video. Stay informed, stay inspired. TimberTalk.